So we want to make a self-driving go-kart that can go as fast as possible and even as fast as a human driver. So first step is to make everything electrified, and second is to add all the sensors and controllers on board so that they can be controlled by a central computer. Then it's writing all the software so that it can go autonomously.
So our work at Penn is to build reference designs for software-defined vehicles, and that allows the software to make all the control decisions on these platforms. And then we share that as open source software. This means that anyone can adopt it. It's very well documented. The code is shared with them. And then they take that design and they develop it to the next level. So the software that we share is based on the Autoware stack. And that allows us to share very well with several hundreds of partners. And together with Autoware, these have been deployed in full-size buses in Michigan, and robo-taxis in Tokyo, and so many more deployments. It just shows that the power of open source allows many people to collaborate together on a very complex problem like autonomous driving.
How do we know what is around us? In order to know that, the go-kart is equipped with LiDARs and cameras. LiDARs essentially shoot out light rays and give us a point cloud data in order to find how far an object is from us. So once we know that, the next step is to kind of localize ourselves. That is, where are we in a certain position? But the complexity here is that since it's a high-speed vehicle, we have to take into the dynamic constraints and model accordingly.
So one of the big questions when we focus on driving here is that we focus on autonomous racing. This means that we are pushing the vehicles to their limits of handling. What we are looking at is this balance between safety and performance, of agility and restraint. So if you're too conservative, then you're too slow and you lose the race. But if you're too aggressive, you crash and you're out of the race again. We, in our research, are trying to learn what is the driving behavior, what is the intention in the mind of the other drivers. And then once we learn that, we have a very good estimate of how they're going to drive, and we can outcompete them.
Working with people from various backgrounds even helped me better understand what I'm doing and also what the system is doing, the behavior of the system. Because even if the software is doing its job perfectly, if there's something wrong in the lower level controller, the car could still exhibit bad behavior. So having a interdisciplinary team, I think definitely help us achieve building this autonomous system.
Rahul's been so far the best mentor I have had. So he's given us the full freedom to explore with any sensor, and any doubt we have, he's always there. Working with Rahul, I think that's one thing that I learned a lot about a project, how to know the system as a whole and be able to deploy softwares that can be used right now. So I think I like autonomous systems in general because personally I don't know how to drive. I'm counting on it to become fully autonomous.